Okay, one last feature of a graph is the turning points of a polynomial function. We actually talked a little bit about that before. So this is what we call the local maximum and the local minimum. The y-coordinate of the turning point is a local maximum when the point is higher than all of the nearby points. So if you're looking at this graph, the local maximum is right here because this y value right there is higher than all of the points surrounding it. So if I cover up everything else, that looks like a highest point of just that region. The y value of a turning point is a local minimum when the point is lower than all of the nearby points. So on this graph, this point right here is a local minimum because it's the lowest point of all the points surrounding it. So you're only looking at one area, one part of the graph. These are also the turning points, right? Because when you go to the highest point and you turn around, that's the point where your graph turns. The turning points of a graph helps you to determine the interval for when a function is increasing or decreasing. Because on one side, the function is going to be increasing, and when it gets to the turning point, it's going to become decreasing. All right, let's take a look at a couple of graph would look like. Okay, so this is example number 3. It says, from the graph of each function on your calculator, identify the X intercept and the point where the local maximum and local minimum occur. And then I want you to determine the interval for which each function is increasing or decreasing. So there are a couple of things. One, they want you to identify the X intercept and the points of local max and local minimum. Okay, so let's take a look. I need to graph this on my calculator, and I graph. So taking my calculator, going to a new graph or new document, adding a graph. I'm going to graph it. X cubed, x to the third power, minus 3x squared plus 6. Okay, my graph looks pretty similar to that. To find the x-intercept, that's where the x-intercept is. And I'm going to find that. That's also called a 0 right there on my graph. So menu, analyze graph, 0, highlight my 0. So my x-intercept, my 0 happens at negative 1.196. Let me write that down. 0 happened at negative 1.196, comma 0. Now we'll talk about local maximum and local minimum. If you're looking at this, there is a local maximum right here and the local minimum right here. So let's local max and local min. So let's make sure we're finding those out. On my calculator, this looks like it's a whole number, but let's make sure. On my calculator, I find that my local maximum is right up here, and I'm going to go on, analyze graph, maximum, oops, it looks like I just, try that again, analyze graph, maximum, and I'm going to highlight just that area, just that maximum area. You don't want to go too far because you're going to catch some of the other maximum. Okay, that's going to be at 0, 6. So local maximum is at y equals to 6. Local minimum is this point right here on the graph. So again, I'm going to find the minimum by analyzing graph. Analyze graph, minimum. Again, I'm just highlighting just that area, nothing else. So you're going to catch some other minimum that's not the local minimum. It's at 2, 2. So local minimum, y equals to 2. Or let me write this down, 0, 6 and 2, 2. Well, this is important because now we're going to have to talk about when is the graph increasing and when is the graph decreasing. Increasing is when the graph has a positive slope. And in this case, if I'm looking at the whole graph, reading from left to right, this part right here, from all the way down to negative infinity, right? It doesn't really have a starting point, and it keeps increasing up until this point. And this is my local maximum point. And if you look at this, local maximum happens at 0, 6. That means the graph stopped increasing at x equals 0. So from negative infinity to 0, that's when the graph is increasing. And then the graph decreases from the local maximum to the local minimum. This is the part when the graph decreases. Well, when does it start decreasing? It starts decreasing at 0, when x equals 0, and it keeps going until we get to our local minimum. The x value on that is 2. So from 0 to 2 is when the graph decreases. And then it turns around, because that's your turning point, and increase back up again. So that's going to give me at x equals to 2, from x equals to 2, all the way up until infinity. That would be my increasing part. So I have 2 parts of increasing and 1 part of decreasing.